Welcome to Pipesim Python Toolkit for Beginners. In previous video, I explained how to run PT profile simulation with different output parameters and report simulation results. In this video, I am focusing on boundary conditions and task configuration. And I also will explain you how to work with sensitivity variables. As usual, I use the case study model to show you example. And in this video, I use the CSV 105 horizontal oil well model. I saved this model in the temporary folder where I have permission to override data. Let's check what we have in this model. So this model includes the well with some surface equipment. On the surface equipment tab, we can see that the model contains connection to two flow lines, choke, and manifold. I'm focusing on PT profile task, so let's check what we have in this PT profile task. In the task, you can see that we have the task to calculate the liquid flow rate with predefined data of inlet and outlet pressure. And in additional, we have some sensitivity data. The branch end for this task is manifold. It's the last node in the system. So I'm going to reconfigure this task and calculate outlet pressure when we have the inlet pressure and known liquid flow rate. And then I will play with sensitivity data. And of course, I'm going to change the branch end because I don't want to include my choke in the system. So I'm going to calculate the well, including the flow line. Let's go back to the code and start investigating this code. So first of all, I need to get information about the well name. For this purpose, I can use a model, find all components, and then filter by model components well. And we have the well name, well, and I want to assign this well name to the variable called well to simplify the code. The second thing we need to do is to get information about the study. Let's copy the same code, model, find, and then we will filter it by study. So we see that there is only one study in this model, so I can assign this study to the variable study1. Okay, so we saved it, and this information will be used later. And we can dig information about the conditions for my simulation task. For this, we need to go to the model, tasks, PT profile simulation, and we have method get conditions. In the get conditions, we have several arguments, so we need to define the producer. It will be the well name, and we need to define the study. Since we have one study, it is not mandatory to define the study name, but I will use it in case you want to repeat it with model with multiple studies. So we have some output information. We can ignore it. It has nothing to do with this current example. We need to focus on this output where we can information about the boundary condition for my PT profile task. We can see that this task is defined for our well, horizontal well. We have clearly defined branch terminator, manifold, and we are going to change it later. Description, we don't care about it. We have the inlet pressure, outlet pressure, and then the flow rate type, liquid rate. And here we have the calculated variable called calculated flow rate. So I'm going to change this boundary condition. And an additional, also you can see that there is a sensitivity variable where we calculate system data, inlet pressure, and using the input different inlet pressure values for our task. So we need to redefine this boundary condition. There are two ways to define the boundary condition. First of all, we can save this output to variable and change some of the values. But I'm going to show you the second way, where we define everything from scratch. So I'm going to create the new variable conditions, the dictionary. And in the dictionary, I want to define the parameters. So let's start from the producer. I will call parameters, PT profile simulation, and we need to select the producer. I will copy these parameters PT profile simulation because it will be repeated multiple times. So let's start from the producer, and the producer, I need to use the well name. The second parameter will be the branch terminator, so I need to define branch terminator, again parameters PT profile simulation, and in my case the branch terminator is flow line name, so we have here FL1. So I will define this variable fl1 as a branch terminator. Now I need to define what we are going to calculate. In my task, I'm going to calculate the outlet pressure. So I will select the calculated variable. And then I need to say that I'm going to calculate the outlet pressure. For this, we have the constants class. And the constants, we have the calculated variable class again. And from the members of this class, I want to select outlet pressure. So I'm going to calculate the outlet pressure, and I need to define boundary conditions, inlet pressure and flow rate. So let's define the inlet pressure. Inlet pressure is there. And what's the pressure was used on this task? So we have 3200 psi. So I will change it slightly and define, for instance, 3000. And then I need to say that I'm going to calculate the liquid rate. But before I define the liquid rate value, I want to make sure that liquid rate is selected, not a gas rate, not a mass rate, but liquid rate. So I need to set flow rate type. And for flow rate, again using the constants class, flow rate type class, I select the liquid flow rate. And now I make sure that the flow rate, liquid flow rate will be calculated. And it's time to define the value of the liquid flow rate. So the value will be, for example, let me check what we can define here. So for current boundary condition, if I remove the sensitivity and run simulation, I can get information about the liquid flow rate. So the current flow rate is 5700 something. So let me define the value 6000, for example. Okay, so I defined these conditions, and I can apply this condition to my task. But before, I'd like to remove all sensitivities. So I will use the model, tasks, PT profile simulation, and here I have an option to delete sensitivities. So I will delete sensitivities. Again, I need to define the producer. It's the name of the well. And study, I use the study one. Okay, so we see that all sensitivities were removed. We can run one more time these get conditions to make sure that there is no sensitivity here. You can see that now the output is free. There is nothing about the sensitivity, and I'm ready to apply my boundary conditions, what I defined here, and the conditions. There are two ways to update the boundary condition for the task. First way is to use the conditions as the argument when we run simulation using the method run. And the second way is to explicitly set up the boundary conditions. I'm going to show you the both way and start from the second one. So I will use model, task, PT profile simulation, and we have the method set conditions. Here I need to say the producer. So we have the producer, well name, then we have the parameters, and here we will say the conditions, because I use this variable to define the boundary conditions, and we need to use the study. Okay, so we see that conditions were updated, and how we can check that everything is applied properly. So we can run one more time this request and make sure that the data were changed. So we see that flow line 1 now is the branch terminator. And I also can do the following. I can save my model and open the model again from the user interface. And then go to well perspective. And for this model, I will run PT profile task, and I see that, we calculate outlet pressure with this input. And let me check if we can get some information based on my input. Yes, we should have 206 psi the outlet pressure. So seems like I defined everything properly. So we can run the simulation. But before I run the simulation, I need to simplify this process, and I need to define the output variables. Let me define profile variable. I will call the prof variable. And here I need to use the list of profile variables, and I think that the pressure is enough. And I need to define system variables. So again, the list, system variables, and maybe wellhead pressure, and maybe something else. System variables, system outlet pressure, because we are calculating outlet pressure, so it's logically needed to define the outlet pressure. And now I can run the simulation. For simulation, I will use model, tasks, PT profile simulation. Then I can define the run. And you can see that we should define the producer. We can set the parameters, but we've already defined the parameters, so it's not needed. And then, of course, I'm going to use the profile variables and system variables just to speed up the simulation. So, producer, well, profile variables, prof var. Okay, it should be this way, and let me just move it another line, prof var, and then we have the system variables, sys var, and then I'm going to use the study explicitly, study1, and I need to save the output, so I will use the results, save the output, and let me run the simulation. Again, we have some warning. This warning I applied only for this model, so we can ignore it. And we see the output that simulation is finished successfully. So if we go to the results, and let's check what's the cases. In the results, we see there is only one case. So let me check. I save this as a case name. And now we have the case, and we can call results systems. Sorry, it should be system. And we have the wellhead pressure, and then based on the case name outlet pressure, we have some value. So I don't want to repeat all this investigation many times, so let me just define the method which will report the system results. So I will do the def print results, and then pass the results variable. And here I will go through all cases, results cases in my model, save each case name as a case, and then I will extract the pressure value from my simulation results. So I will go to results, system, and then use the system variables, system outlet pressure. You remember that we use system outlet pressure as the input here, so we already requested this information from the model, so it should be there. And then I need to use the case name. And then I need to print the output, so I'm going to use the F to print, and I will use the case. And for each case, I need to print pressure value. Okay, so this is the method I'm going to use to output the results for all cases. Let me check how it works for my case. So we have the output. Since this is defined PT profile without any sensitivity, so we do not expect multiple results. I expect only one value, and we've got this 206 as output, and this is my case name. You can see that the case name already includes this output result. But anyway, so the system output is 206. So now I think it's time to define the system variables and see how it works. Let me scroll up slightly and find the first output where I requested the conditions. If you remember that when we opened the model, that model contained information about the system sensitivity variables. So in the sensitivity variable, we use this component and we define the system data. We use the variable inlet pressure and some values were defined. So I need to define the same structure and apply it to my conditions. For this purpose, I'm going to create a new dictionary, call it sensvar, will be sensitivity variable. And in this dictionary, I need to define parameters, PT profile simulation, sensitivity variable, and I will copy this structure because it will be used many times. And then we have the component, and we need to start from the component. Component will be system data, and then I want to define variable. For this purpose I use inlet pressure, and we need to define values. And for values we need to pass the list of values. I use 3000 inlet pressure. Let me use 2800 and then 3000 and 3200. So this is sensitivity variable, and I need to add this sensitivity variable to my conditions. So you remember that I use the conditions. The conditions have this shrinked input. So let me redefine the condition one more time. Let me find where I did it. So we had these conditions. I'm going to use these conditions. I will define it here, and I will add one more parameter here. I need to use parameters, PT profile simulation, and we have sensitivity variables. Sensitivity variable. And we need to set my dictionary. So the sensitivity variable will be sense_var, and we need to define it. Okay, so it was defined, and as usual I have two options. I can explicitly define the new boundary conditions, or I can use the conditions as the argument when I run the simulation. So let me show you the second way. I'm going to copy all these things with the results. So I will run the simulation, use the producer, and then profile variables and everything. But in addition, I want to set here parameters. So we have the variable argument parameters, and then I will pass the conditions here. And let me run the simulation one more time. So simulation is running, and now we can print results. Print results, and I will pass the results as argument to my method. And you may see that we've got three outputs. For each inlet we have the outlet. So for 2800 we have the outlet 87 psi to produce our flow rate, and for others we have the other outputs. So that's all what I wanted to show you. Remember to close the model when you finish your exercise.